Alright y'all, so in this video I'm going to give you a basic intro to limits from a graph like this one. So it says find the following limits for the function f of x shown below. So I see this piecewise function and we're going to be taking a look at what these limits are and how we can kind of translate them and look at our graph to find what they're equal to. So this one says the limit of f of x as x approaches 1, and this little sign right here, this minus sign, means from the left. This says the limit of f of x as x approaches 1, and this little sign means from the right. And this third one says the limit of f of x as x approaches 1. So we're going to be looking at both from the left and from the right and thinking overall, where is the function headed as x gets closer to 1. So what we're thinking about for this first one is, if we think of the left side of 1, so numbers that are slightly smaller than 1, what's happening to f of x, or the output of my function. So let's look at the graph. Let's come over here to 1 and think about the left side of 1, which would be this side over here. And if I cover up the right side right here, I see that my function, if I have numbers really, really close to 1, like 0.999, those would be a bunch of points right here, and they all look like they're approaching this point, getting closer and closer and closer to this point, which has a y value of 2. So my output there, or my limit, would be 2. If I look from the right, then I'm going to cover up the left-hand side, and I'm looking at values just bigger than 1, like 1.01 or 1.1, and all of those have outputs that are up here, and it looks like as we get closer and closer to 1 from that side, we're headed to this point. Now the point itself doesn't exist, but that doesn't matter. We're talking about what these values are approaching as we get really, really close to this point, but we never actually reach the point. And it looks like that's at an output of 4, so the limit from the right would be 4. Then we need to find the limit as x approaches 1 overall. So like I said, we're now going to be comparing our left and right approach. If these match, if it's approaching the same number, then that's going to be our limit overall. If they don't, like in this case, then we're going to say that our limit does not exist, and you can abbreviate that D and E. Okay, so now that we have a little bit of an idea what's going on, let's go ahead and try another one. This one says the limit as x approaches 8 from the left of our function f of x. So let's go out here to 8, 4, 5, 6, 7, 8. And again, if I look from the left at numbers just smaller than 8, those would be right here, headed towards this point, and that point is at a y value of -6. From the right, we'd cover up this side. We're looking for numbers slightly bigger than 8, 8.1 or so would be right here. These values are also approaching this point right here at -6. So this time our left and our right match, which means our limit overall would also be -6. Last two. These two are kind of off on their own. I've got the limit of f of x as x approaches -1. So this one is similar to these last two up here, where I'm looking for the limit overall. So I need to find the left and the right approach for this one as well to be able to find my overall limit. So let's go to -1. From the left, it looks like I'm approaching 2. And from the right, it looks like I'm approaching 0. So that means overall my limit doesn't match, so it does not exist. Okay? Last up, the limit of f of x as x approaches 4 from the left. So let's go to 4. And I don't care about the right, I'm just going to look at the left side right here. And I see my function getting really, really close to 4 right here, approaching this point, which is up there at +4. Okay? So when we're looking at limits, we're looking as our x value heads closer and closer to a value, where does it look like our y values are headed?